What's up guys, I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video we are going to tackle data science interview questions number 6 to number 10. So before we begin guys, I'd like to mention to you, right, if you can hear the sound or the pitter patter of water droplets, it is because it is raining outside currently, and just to get that out of the way. Yeah, so we can actually begin now. Data science interview question number 6. What is the importance of data cleansing in data analysis? Okay, so logically speaking, right, data comes from a variety of sources. In the real world, data comes from a variety of sources. Therefore, it is critical to make sure that the data is fit enough for analysis. You see, this is where the process of data cleansing plays a very critical role. Data cleansing is a broad term that refers to the process of finding and correcting data records, ensuring that data is complete and accurate, and those irrelevant data components are eliminated or amended as needed. This procedure can be used in conjunction with data manipulation or batch processing. Now, you guys will agree with me, right? So based on what we just read, and the question now is also saying the importance of data cleansing. So they are asking us, what is the importance of cleaning the data before we perform analysis on the data? Now, you guys should understand that, you see, data, there's this term that is often used. It's called data storytelling, right? Or telling a story using data. Now, the thing is, if that data is incorrect or inaccurate, or it's not prepared or written properly to tell the story that you are going to convey, right, from that data, it is not going to be accurate. You are going to make decisions and base your decisions for the company of data that is not 100% in the correct state or format. Okay, so just keep that in mind. Data cleansing is always an important and crucial aspect of data science. Now we have data science interview question number 7. What is the difference between univariate, bivariate, and multivariate analysis? So these are analysis approaches with a single, double, or many variables, as the name implies. So uni is 1, bivariate is 2, multi is 2 or more. So as a result, univariate will only include one variable, and there will be no linkages or causes as a result. The main goal of the univariate analysis is to summarize data and uncover patterns in it so that actionable judgments can be made. The link between two sets of data is the subject of bivariate analysis. These matched data sets are derived from linked sources or samples. When the data has a correlation, numerous methods such as chi-squared tests and t-tests can be used to assess it. If the data can be quantified, a graph plot or scatter plot can only be used to study it. The bivariate analysis will be used to determine the strength of the correlation between the two data sets. Okay, so that's what we have there. Now, on to data science interview question number 8. What industries or fields use machine learning in the real world? Now, just off the top of your head, guys, I'm sure that you guys can really collect quite a few fields that actually implement or utilize some form of machine learning in the real world. Like, logically speaking, right, machine learning has the ability to be applied to any field. Okay, to put it bluntly and logically spoken, any field, because I cannot think of a field in which machine learning will not have the capability or the ability to partake in. Okay, anything that a human being can do with proper machine learning techniques, a machine will be able to do exactly that, and I will argue even better. Okay, so here are some examples of how machine learning can be used in the real world. E-commerce, understanding customer attrition, executing customized advertising, and remarketing are all important aspects of e-commerce. Search engines. This is a good answer to provide during your interview. It ranks pages based on the search's particular choices. Finance. Identifying and evaluating investment opportunities and dangers, as well as detecting fraudulent transactions. Medicare. Developing medications based on the patient's medical history and requirements. Robotics. This is another good example to mention. Robotics is the use of machine learning to deal with unusual situations. Social media. Understanding relationships and proposing links on social media. Extraction of information. Information extraction entails formulating questions in order to obtain answers from databases accessible via the internet. So basically web scraping, guys. Web scraping is a powerful application of machine learning, and within this little image here you can see there are good examples of applications of machine learning in the real world. So that is what we have for number 8. On to number 9. What are the different aspects that contribute to solving a machine learning problem? So quite a bit of stuff to go through here, but let's go through it together. Number 1, we have, so just to clarify, this question is asking for the different, I would say, components that need to come together in order to, solve any machine learning problem. So these are the components. Number 1 is domain knowledge. This is the first and foremost step in which we need to learn how to extract various aspects from the data and gain a better level of understanding of the data that we are dealing with. It has to do with the type of domain we are dealing with and familiarizing ourselves with the system in order to understand more about it. Number 2 is feature selection. This stage is more concerned with the feature that we are choosing from a list of options. There are instances when there are numerous features available and we need to make an informed selection about the type of feature that we want to use in order to proceed with our machine learning endeavor. Number 3, algorithm. This is a critical phase since the algorithms we select will have a significant impact on the entire machine learning process. You have the option of using a linear or non-linear approach. Support vector machines, decision trees, naive Bayes, and k-means clustering are some of the techniques that can be employed to tackle that machine learning problem. Okay. Number 4, training. The most crucial aspect of machine learning is training, which is where it varies from traditional programming. The training is based on the information we have and includes more real-world scenarios. With each subsequent training step, the machine improves and becomes smarter, allowing it to make better decisions. Number 5, evaluation. In this phase, we really assess the machine's decision to see if they are up to par. There are several indicators involved in this process. We must close deploy each of them in order to determine the efficacy of the entire machine learning effort. Number 6, optimization. This procedure entails employing numerous optimization strategies to improve the performance of the machine's learning model. One of the most important aspects of machine learning optimization is that the algorithm's performance is substantially enhanced. The best thing about optimization strategies is that the machine learning model or machine learning itself not only consumes optimization approaches but also generates new optimization ideas. Last but not least, we have number 7, which is testing. Several assessments are carried out here, some of which are unknown test cases. The data is divided into 2 groups, test and training. In order to effectively deal with diverse circumstances, several testing approaches such as cross-validation are used. And guys, those are the 7 steps that we bring together, the 7 aspects that come together in order to contribute to the process of solving a machine learning problem. We have domain knowledge. That's knowledge about the problem or the task itself. Feature selection has to do with selecting the features. Features refer to the columns in the data set themselves. The algorithm is the methodology. Training, the process of applying, releasing the algorithm on the data. And we have number 5, evaluation. We assess the machine's capability to predict and decide. Optimization, we give the machine's algorithm or the model that little boost in performance. Last but not least, testing. That's when we test the machine or the model on real world data, preferably data that it has not seen before. Okay, that's how we can best judge the capability or the ability of the machine learning model itself. Now, the last question and answer for this video, we have question number 10. What is meant by normal distribution? So, normal distribution, it is a group of continuous variables that are dispersed across a normal or bell-shaped curve. It is useful in statistics and can be thought of as a continuous probability distribution. The normal distribution curve is the most frequent distribution curve, and it is particularly useful for analyzing variables and their interactions. The symmetrical normal distribution curve. As the sample size grows, the non-normal distribution approaches the normal distribution. The central limit theorem, CLT, is also fairly simple to apply. This method uses a bell-shaped graph to help make sense of random data by constructing order and analyzing the results. So this is an example of the bell-shaped curve. I'd like to also just mention, guys, you guys should probably know this as the Gaussian distribution or the Gaussian curve. Either way, it refers to the exact same plot, this bell shape itself. So that is what we have for this video, guys. I am ready to conclude now. So with that, thanks for watching, guys. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.